All right. For this function, it starts out with the time t, so it takes the time and it sets it at start, which is time null, which is the current time, which is used in the include time age function. And the next thing is the int step, which initializes the steps, which counts through each time the letter is clicked. And next initializes the start values of the y value, which is 9 right here on the maze, and an x value, which is 0 right here. And then it sets a constant integer for the x and y values for when you finish the maze. And the x value is 49 over here, and the y value is 9 right here, and 39 right here. And then we set character movement, which is for each time the user enters a letter to move the maze. And then here's our maze, which is 50 by 50. And it spells out CS351 beautifully. And then whenever you get to the escape value, whenever it equals the escape value right here, the system will clear everything and it'll tell you how long it took, which is the current time right here, time null, which is subtracted by the start time, which was earlier on in the program, which will give you the actual current time, whatever you finish the program. And then it'll tell you how many steps you beat the game in by counting after each time a character is moved right here. So it adds 1 each time A or D is moved, and then 1 whenever W or S is moved. And then in main, after each time something is clicked, it will reset with the maze right here, and then it'll tell you how many times you've moved, and then ask you what you should put in, and then it goes on to here. Dougie.
So the two if and else if statements right here, it's for A, movement A and D, which is the X movement. If you see X value equals the pointer X movement function, that'll be for that function below, and then it'll tell you how many steps. And then the else if it's W and S, that's for the Y values. And if you scroll down, and if you scroll up all the way, we have our functions initialized right here, right below time H, and for print maze, X movement, and Y movement. And you can see the variables used for that. Go back down. Down a little bit more. Okay. For X movement, this is pretty much the same as Y movement, except the cases for A and D. Zach, if you want to explain those.
All right. So the cases for X movement and Y movement are what determines user input on which direction they can turn. If you look at case A, for example, it'll recognize capital A or lowercase a. The if statement below it recognizes that the X is greater than 0, which means that the player isn't moving out of bounds of the array, and that the maze Y with the coordinates y, x minus 1 actually equals an empty space and not an asterisk, which would be a wall so the character couldn't move. So the if statements actually prevent the player from making illegal moves, only allowing them to make legal moves. Let's see. I think that's pretty much it.
Actually running through our maze. Here we go. We can run through it really quick. You can enter each letter one at a time or multiple characters at a time. And as you can see, I'm trying to go down and there's a wall and it will not let me. And after each time I enter a character that is successful, it will add it to the movements below to count how many times I've moved in total. And all while I'm finishing or doing this program, it's counting how long it took me to complete it with the time age function.
And the multiple characters will count if it hits a wall too. It's one thing to note.
You can also do multiple characters that are separate, as in going down and then trying to go right. It will still do that, so it'll jump all the way over to there. And keep going. Oof. Pass it up. And we're approaching the end here. And then it took us 90 seconds to complete, and we completed it in a total of 193 steps. So that is our complete program, and that's how we got it.